Kia ora! We're having a look at pages 60 to 62, and that is on the subject of rate of change using anti-differentiation given a point. So I've got this as an example today. So Mr. Forbes has a cactus that he is growing, and we're going to say that this cactus currently weighs 100 grams. Right, so Mr. Forbes is growing a cactus. Oh shucks. It's the thing. When you're growing a cactus, it gets wet. Mr. Forbes is growing a cactus that currently weighs, let's just assume that I weighed before and after the soil, currently weighs 100 gram and is growing at the change in weight over, oh come on, did I get my pen wet? No! Change in weight over time, as the weight changes over time, so weight changing as time changes is 0.1 t plus 0.2. Right, so this cactus currently weighs 100 grams and it's growing at this rate. The weight is changing in regard to time using this formula. Right, now let me just now what we are going to try and work out is two questions. How long until this cactus doubles in weight? How long until it doubles in weight? And question two, we're going to ask, how heavy will it be in a year? In 1 year's time. And for this one, we're going to say where t is in days. T is in days. Okay, so we're talking about this cactus. The thing is with these problems is that the context is probably going to be the hardest thing to get your head around. So what you really need to make sure of is what are the two variables that you're looking at. So in our instance, I've got a Desmos graph up here. So we're looking at here, we're looking at how something changes over time, and we're looking how the weight is changing over time. So we're starting off with a derivative, right? So we've got, so far, all we've got is our derivative. We've got dw over dt equals 0.1 t plus 0.2. So with any of these problems, they're also going to give you a point, right? Given a point. So what is our point? So we know that the cactus currently weighs 100 grams. So we've got 100 grams, but what is the current time? Now, a really common thing in these things, a really common case in these questions is that the initial time, most of the time, it's going to be 0. And here we know it's 0 because we're measuring from current. See how I've got the word current here? So we know that the initial time is 0 and that the initial weight is 100 grams. So we have a coordinate. So let's plot that right now. So our coordinate is going to be that x is equal to 0 because the time is 0, or t would be 0 should I say, and the weight is going to be 100. So we've got this coordinate that we are working with here. So what we're going to then do is we are going to anti-differentiate. So if we've got change in weight over change in time, it will anti-differentiate to w. So we'll go w equals, and let's anti-differentiate this. So first we increase the power by 1, so t to the power 1 goes to t to the power of 2. And then we divide it by the new power, so over 2. Then we do the same here. So currently we've got t to the power 0, so it's going to become t to the power of 1 divided by 1. That will stay the same. Then we have our constant of integration c. So now we have a formula for our cactus, but not quite yet. What we know though is that when t equals 0, then the weight is 100. So this is going to be, so let's work that out. So 100 will be, this whole thing will become 0. This whole thing will become 0. The reason being is because 0 to the power 2 times that divided by that is going to get you to 0. And then 0 times 0.2 is going to get you to 0. And then that helps us find our c value. So then we can say that 100 is equal to c. So I'm just going to change it here because I'm going to run out of space. That will make c equal to 100, and then we can substitute it up here. Okay, so now we have a formula. We have a formula to work with, and this formula is going to be what we use to solve questions from now on. So let's just do that formula. I copied it earlier. So now we have a formula for how our cactus is growing. So let's just quickly focus on what's actually happening here. 0.1t plus 0.2. Oh no, that's got to be Desmos. I'm just using an x, hopefully that doesn't confuse you. Now, the green is the rate of change of my cactus as it changes over time. But as you can see, when we anti-differentiate that, it becomes a parabola because we've got a positive linear line, and it becomes a parabola. So the weight of my cactus is going to be increasing from 100 grams, and after what, 10 days my cactus will end up being about 107 grams, and then it will keep growing and growing, and my cactus is actually going to be growing increasingly faster, right? So as your plant gets bigger, its weight's going to get bigger and bigger. Anyway, we've got this formula. Let's answer the question. So number one, how long until it doubles in weight? So what we're going to have to do for that is we are going to have to do a substitution. So when would the weight double? Well, we know that the initial weight was 100. So if we double that, 2 times 100 equals 200. We want to know when W equals 200. So let's do that here. We just substitute 200 in here, and then we're going to have to solve using, probably best to use our calculator to do that. But you know what? I'm going to cheat. You guys will have to solve that using your calculator. All I'm going to do is I'm just going to go and find out when my cactus gets to being 200. So it would be at this point here. Not quite. Right? My cactus doubles in weight after 42.9 days. So the thing is with these questions, or should I just solve it for you guys? Nah, too lazy today. So it's going to be when the weight, so it's going to be when y equals 200. Let's find an exact value for you. It would be this point here. So it's when t equals 42.77. That would be when w is 200. So for question 1, it's when t equals 42.77. But the thing is, our weight is only measured in days, so what we have to do for these is we have to round up. So it's going to be, and we'll do it in context, after 43 days is when the weight of the cactus will double. Now, next question, how heavy will it be in 1 year's time? Well, we all know in mathematics that 1 year is equal to 365.25 days, because we've got to account leap years. So what we're going to have to do is we're going to have to go and substitute t equals 365.25. As you know, I'm in a lazy mood today, so let's just cheat. X equals 365.25. So let's have a look when that happens. So our cactus will be, in 1 year's time, this is very accurate, very scientific approach, our cactus will be 7 kilograms in 1 year. Right, so the answer to question 2 is 6,000. 843.43 grams after 1 year. Now you would have to use some actual, like a calculator to do that probably, but yeah, the idea of these questions remains the same. Rate of change, what they'll do is they will give you a derivative function and a point. Generally that point is going to be an initial time, and then they'll give you an initial weight, so it will give you a coordinate. You will integrate this or anti-differentiate it. That will give you an output, and then this function is what you're going to be using to answer the questions. Only very rarely are you going to use the derivative to answer those questions, right? So I hope that helps.